Hey, what is up? It is me. It's another day. I'm happy to be here, and you're happy to be here. Otherwise, why would you be here? Unless you like the sound of my voice and ASMR is your thing, and immune system ASMR is cool, and maybe I will create that and profit off that. But I think you're here more for details about the immune system. Okay, well, today I'm going to give you my ASMR talk on the immune system, and we're going to review some things we talked about already. Okay, because before we get to some more involved topics and deeper structures of the immune system, we're going to have to make sure we understand all the basic things, or at least at a higher level. And I've gone over the breakdown of cells before in a video a few days ago, leukocytes, lymphocytes, and the other cells of the adaptive and innate immune systems. And now I'm just going to kind of go over an overview of, all the large pieces of these and their course of action. Okay, so, and forgive me if I sound a little like fuzzy. I'm going to try to make sure that all the pieces work out as I speak to them and fit nicely together. If they don't happen to in this video, then in a future video I will iterate and make this more presentable verbally. Okay, so the innate immune system. What is it? It's the first thing that gets activated, and a pathogen, let's say a pathogen, infects your body through a splinter or something like that. At the site of infection, as the splinter has breached your skin, let's say there's some kind of bacteria that filters into your immune system, filters into your skin through and down through the wound. The first things that come into play, the first parts of the immune system that are active are the immune cells that are closest to your skin surface, which are your dendridic cells and your mast cells. So this is all basic stuff, but your dendritic cells are basically immune cells with lots of branches called dendrites, and they have similar structure to astrocytes and dendritic cells and neurons in your nervous system, right? But these dendritic cells are specifically have actions of immune cells. For example, they have antigen presentation, they have phagocytic consumption, and they move to your lymph nodes. The dendritic cells are actually quite important because they are the connection between your adaptive and innate immune system, but I'll get to that in a bit. Your mast cells, essentially, when a wound is detected, and they have receptors to detect pathogens that come to them after a wound has been created in your body. The pathogens bind to the non-specific receptors of the mast cells. So remember, non-specific is one of the key phrases to innate immunity. The antigens bind to the non-specific receptors on your mast cells, and when that happens, the mast cells start to emit histamine and heparin and other pro-inflammatory cytokines. So the histamine and heparin are meant to interact with your blood vessels and expand them. Remember we talked at one point about vasodilation. So the blood is where the leukocytes are flowing, and that's how they travel to the site of your infection, and they need to get there faster, and they need to get there in greater volume, so the blood vessels need to expand. This process also allows for leakiness and porosity of the blood vessels to occur. Blood vessels are smooth muscles, so have smooth muscles surrounding them, so the blood vessels can contract and expand. So their junctions, their T-junctions between the epithelial cells and the blood cells are broken temporarily, and then the pores form within the blood vessel walls, so that macrophages can and other cells can take shortcuts from your extracellular space, extracellular matrix, and other body tissues outside of the blood cell into the blood cell, because they can't just always rely on a direct route to the site of infection through the blood vessels. So they need to take shortcuts. So that's basically what the mast cells do. They allow for vasodilation and vasoporosity, and they also emit these cytokines, and the cytokines then signal your fills, right? They signal, and macrophages, they signal other granulocytes and cells which are involved in the destruction of the pathogens that are in question. Your dendritic cells, in the meantime, also release these cytokines, and these cytokines there's a number of cytokines involved, interleukins and interferons, and there's other cytokines which essentially chemotactically call these other parts of the other cells in your immune system to travel over to the site of infection, right? So this is all, again, part of the inflammatory response, okay? So attraction of, if you look at the phases here, attraction of leukocytes is one phase, right? So we want to do that, and then what happens is the other parts of your immune system are triggered as well. There's systemic response, which is the proliferation of leukocytes, and fever, which is done through pyrinogens. All these are initiated through the actions of the dendritic and mast cells. So afterwards, what happens is that your mast cells then, your dendritic cells then, they ingest some of the antigen non-specifically, and this is where the immune system, the immune system needs help, right? Because these dendritic cells will ingest things that they determine to be pathogenic in a just very brute force, blunt way, and they will break up internally. They will lyse these pathogens, and they will present a piece of that pathogen called the epitope, antigenic epitope, on their major histocompatibility complex. So basically now they're holding up this piece of a body, right? And they take that to the lymph nodes, as I was talking about earlier, and in the lymph nodes, that's where they talk to the other cells, the T cells and B cells and other cells involved in your humoral immunity response, right? So the macromolecular immunity, or adaptive immunity, or antibody immunity, whatever you want to call it. But this is necessary because where your innate immune system is tackling anything that could be pathogenic, right, and may even miss the pathogen and actually just destroy the body, the adaptive immune system will now go through processes we talked about in previous videos, where the dendritic cells interact with the T cells, the helper T cells. The T cells then, through their T cell receptors in the major histocompatibility complex, become activated and proliferate in the lymph nodes, and then they talk to the B cells, and the B cells can also interact with dendrites. The mediation of the T cells is important because it speeds up this process a lot faster, and also for other reasons. But anyway, then the B cells ultimately start differentiating into plasma cells and memory cells, and we talked about those. The plasma cells produce the antibodies. The B cells have antibody receptors, etc. The plasma cells produce the antibodies, which are the Y-shaped molecules, which have antigen detection regions on the tips of their active regions, and they interact with these antigens, and so the adaptive immune system is activated, and the memory cells store the instructions how to recreate that antigen, and later on during a subsequent infection they will once again appear, and they will start to produce those old antibodies again when they are needed, in a much faster rate. So that's basically the immune system responses, like the adaptive connected to the innate. And remember, in the background, that's something that's always going on, is the complement system, right? The complement system is also a primordial variant of the immune system, which is also interacting with the adaptive and innate immunities. and also directly interacting with cells and opsonizing cells and creating membrane attack complexes on pathogenic cells and things like that. So just jumping back to the innate immune system, part of the innate immune responses are the granulocytes. We talked about those before. So those are the eosinophils, the neutrophils, and the basophils, right? And remember, all of those are distinguished in their activity. The neutrophils are similar to the macrophages in that they float to the pathogens, they ingest the pathogens and digest them. And then the eosinophils are responsible for dealing with parasites and allergens, and they are part of the allergenic response that occurs and that could be harmful to people. But yes, they also they have ways of and then the basophils are the final cells, and they have their own variant of action within the immune system, the innate immune system, and they're not the final cells, I'm sorry. And then afterwards you have your natural killer cells, right? Your natural killer cells, I haven't talked about them so much yet, but your natural killer cells are very important. But what they do is they detect infected cells and cancer cells non-specifically, and when they do that through the non-specific receptors, when they detect these cells, they will lyse them, all right? They'll create pores in them, and then your macrophages will come by and consume the remnants of that killed cell and recycle the pieces and whatnot. But that is one thing that's important, because the natural killer cells act non-specifically, and that's part of the innate immune system. And the reason why the adaptive immune system is smarter with its own killing process that kills cancer cells and infected cells is that they use killer T cells, or CD8 positive cells, and those killer T cells, those are specific to a specific pathogen. Remember, because those are activated by the dendridic cells, and essentially they're part of the differentiation process of T cells after they've been activated by the dendritic cells. So they are targeted, and that's important because that once again avoids your body from killing itself. So something I don't understand yet is how the natural killer cells action, how effective it is of non-specific determination of pathogenic activity and killing of cells differs like in mechanism and also effectiveness. Like, why do we need the natural killer cells if we should be relying on the killer cells? If it's all non-specific, isn't there a much greater risk with the natural killer cells, or is that somehow mediated evolutionarily by the T cells, the killer T cells? That's a question for another time, but I just wanted to leave you with this somewhat, more detailed than normal for me overview, but there's many images which you can look at and kind of get the gist of what's going on. Okay, that's pretty much it. I will see you another day.